All right, Theorem 8.3, or Section 8.3, we get into reasoning and showing how a quadrilateral can be proven to be a parallelogram. So in 8.2, we talked about the properties of parallelograms. Now we're going to use those properties to prove something's a parallelogram. So Theorem 8.7 says, if both pairs of opposite sides are congruent, then a quadrilateral is a parallelogram. And 8.8 says that both pairs of opposite angles are congruent, then the quadrilateral is a parallelogram. So if opposite sides are congruent, it's a p-gram. If opposite angles are congruent, it's a parallelogram. So if we take a look at example 1, solve a real-world problem. In the diagram at the right, segment AB and segment DC represent adjustable supports of a basketball hoop. Explain why ABCD is a parallelogram. So we look at the shape over here. These are opposite sides, and they're congruent. And then right here, these 18-inch sides are opposite sides, and they're congruent. So that shape is a parallelogram because the opposite sides are congruent. So how we can write that is we could say opposite sides congruent implies p-gram. So basically, if the opposite sides are congruent, we know what's a parallelogram. Okay, and then will segment AD always be parallel to segment BD or BC? Why? So will, let me get a different color here. Will AD always be congruent to BC and Y? The answer is yes, it will. And that's because it will always be a parallelogram. And since we know that the opposite sides will always be congruent, we know it's always going to be a parallelogram. So I'll say yes, opposite sides will always be congruent. So it's always a parallelogram. All right, Theorem 8.9 says that if one pair of opposite sides is congruent and parallel, then the quadrilateral is a parallelogram. And Theorem 8.10 says if the diagonals bisect each other, then the quadrilateral is a parallelogram. Okay, so example 2, if you look at the picture on the right, so quadrilateral ABCD, is this a parallelogram? The answer is yes, because the one pair of opposite sides, this pair is congruent and parallel. So we would say down here, this is actually what the problem's talking about, the headlight of a car. Explain how you know that ABCD is a parallelogram. And we would say one pair, opposite sides, congruent and parallel would mean it is a p-gram. All right, checkpoint. In quadrilateral GHJK, the measure of angle G is 55, the measure of angle H is 125, and the measure of angle J is 55. Find the measure of angle K and explain how you can verify that GHJK is a parallelogram. So if we draw this picture, GHJK, the measure of angle G is 55. The measure of angle H is 125, and the measure of angle J is 55. We want to find the measure of angle K. So let's start by doing that. This is a quadrilateral, and quadrilaterals add up to 360. So to find this missing angle, angle K, we would do 360 minus 55 minus 125 minus 55. Okay, and that would tell us what angle K is, because the whole thing is 360 minus those three angles would give us 125. So angle K is 125 degrees. Then we have to explain how we can verify that this is a parallelogram. So to verify it's a parallelogram, we have to think back to our theorems above. And if we look back, theorem 8.8 says if both pairs of opposite angles are congruent, it's a parallelogram. So down here, both pairs of opposite angles are congruent, 55 and 125. So we'll write that down. Both pairs, opposite angles congruent means it's a p-gram. So that's how we can verify that that was a parallelogram. And then in number 2, explain how you know the quadrilateral shown as a parallelogram. Well, this one gives us the diagonals, and we see that the diagonals cut each other in half. So explain how you know the quadrilateral is a p-gram. We'd say diagonals bisect each other. So it's a parallelogram. So that's how we can tell that one is a parallelogram. And then example 3, use algebra with parallelograms. It says, for what values of x is quadrilateral PQRS a parallelogram? So if this is a parallelogram, the diagonals would have to bisect each other. So that means that those two parts would have to be equal. So 5x would have to equal 2x plus 9. So we solve this for x by subtracting 2x. We will get 3x equals 9. To get x alone, we divide by 3. So x equals 3 would make this a parallelogram, because if x is 3, then those two parts would be equal. All right, and then our last checkpoint. For what value of x is quadrilateral DFGH a parallelogram? So if this is a parallelogram, the diagonals would bisect each other, meaning that these two parts would have to be equal. So 4x minus 7 would have to equal 2x. So if we solve this equation, if you subtract 4x, we would get negative 7 equals negative 2x. And then we would have to divide by negative 2. We would get x would equal positive 3.5. So those are ways we can find out if a quadrilateral is a parallelogram, and that's all we got for this section.